Welcome everyone this evening to this event from the Energy, Environment and Climate Action Division of Engineers Ireland. It's great to have you joining us virtually again this evening, and a really interesting event on the Supernode, which is, I guess, a key enabler to the further decarbonisation of electricity grids in Europe, certainly, and further afield. I'm sure John has great plans to tell us about. Our speaker tonight, we're very fortunate to have John Fitzgerald, who is the CEO of Supernode. John is an electronic engineer and he has an MBA from the UCD Business School. Prior to joining Supernode, John had various roles within EirGrid, including being the project director on the East-West Interconnector, a seminal project, I guess, in Ireland in terms of bringing us into the next level of renewables integration ahead of the 2020 targets we had. And from then, John progressed on to be the director of grid development and interconnection within EirGrid, another key role in terms of development and deployment of the grid for the 2020 targets. So delighted to have John here tonight, and he will give us a fantastic presentation, I'm sure. So I'll hand over to you, John, and we'll take Q&A at the end. People can add questions as we go into the Q&A at the bottom of their screens. Okay, thanks all. Handing over to you, John.
Thanks very much, Bernice, and good evening, everybody. So thanks for taking the time. I'm delighted to have this opportunity to speak with the IEI committee. So the presentation I have this evening that I'll share with you is split into three parts. There's 6 items on the agenda, but it's split into 3 parts. So I'll start off by just setting the context, and the focus for me really here is on decarbonisation by 2050. So not really 2030, but getting all the way to 2050 and really reflect the aspiration that Ursula von der Leyen set out upon becoming president, where she said she wanted to make Europe the first climate neutral continent in the world by 2050. And to make this happen, we must take bold steps together. And I think the bold steps is a very important word. Talk can be very easy, but actions, they need support and resources, and good, clever actions require a vision or a plan to guide them. And I think that the bold steps and the vision and plan are the bits I really want to focus upon here. So electricity powered by renewables can be the vector for decarbonising our economies competitively. And the questions we have is, can Ireland, in the context of Europe, and Europe in the context of the wider world, take the bold steps that are required? So first off, it's insightful to look back at our past and try and learn before we forge a way forward. So to start off with our energy systems, it became natural monopolies back in the 100 years ago, and we pooled our resources and we got better resources on a single network, and they were national networks ultimately. And the big lesson there was that pooling our resources over a network gets us much better cost and reliability outcomes. And engineers, many of you here tonight will be working for utilities, and we're very good at putting in place very reliable and affordable systems. So the systems we have today, where you can turn on the light switch and it'll work, where you have huge reliability and it's pretty affordable, and really work very, very well. And that in itself is a major success that I want to acknowledge. Now, oil crisis came in the 70s before I started working. I'm old enough to remember the queues at the filling stations and the rationing of petrol. That really triggered a policy response because it was a major shock to the system. And a significant shock is needed to overcome business as usual inertia, because we have a very good system and it takes a lot to trigger change in that. My slides are scrolling ahead of me a bit. So electricity generation then opened up to competition, and we saw a huge amount of new players coming in with Directive 9692, and that drove a lot of innovation. Initially, renewables came in and they had subsidies. The diversion away from oil saw us have a lot of gas coming on board, but renewables was really the key thing that triggered and set us up nicely to try and start addressing climate sustainability. So we knew the end of oil was coming, but we didn't know whether we had a viable alternative. And the recent learnings tell us that technical innovation, when that was opened up to the wider market, it drove the prices below fossil fuels in recent years and saw the scale of the projects climb from kilowatts to megawatts. And now we see gigawatt wind farms in the North Sea, which is the world leader. So the wider involvement in competition and innovation gets better results. That's the number 4 learning for me, looking back at the energy sector. Then we look at what we have. So we have enough generation technology to power the global needs several times over, with floating offshore solar, batteries, onshore wind, offshore fixed bottom. We have a huge amount. The question is, we have the finance, we just need the systems to bring it to market reliably. So a recent speech given some years ago called The Race of Our Lives talked about climate change, and it is an imperative. And you can see in the picture here all the effects we're seeing, and there are very few, if any, deny that climate change is really with us now. We see the seas warming, our habitats affected, the weather more severe, droughts, fires, and few countries haven't been affected in a serious way. And I'm thinking back to a second politician, a former president of the European Commission, Jean-Claude Juncker, who said once, "We all know what to do, we just don't know how to get re-elected when we've done it." This isn't a political speech, this is a speech to engineers, so I'm not a social scientist. But this was said in relation to carbon tax. So it's very difficult to upset the system without upsetting people, vested interests. So there's a real challenge here, and we're in a race, and I think the race of our lives. So bringing this back to the context of the Institute of Engineers of Ireland, and those of you listening in tonight, members, I think the challenge for engineers, we have to look back at why many of us became engineers. So I filled in my CEO form and became an engineer, and many of you did too, hopefully correctly, and you're happy with your choice. But the reasons why we did it was because we wanted to understand how things worked and solve them, fix problems. We were in the solutions business, and that's really what brought us into this. And I think that puts us in a unique position to diagnose the issue and be a voice, an important voice that guides our government and our policymakers in how they tackle this major challenge of our time. Our predecessors designed the electricity, the energy, the gas networks pretty much over the last 100 years, and we operate it very reliably today. We tweak it from time to time, competition, diversity away from oil, new devices, new technologies, nothing major. Problem is, with the degree of change and weaning ourselves off carbon, that's not going to get us there. We, as engineers, have a leadership duty to society to espouse a plan for decarbonisation. The plan won't be perfect. It may not be the outturn plan, but a real plan to look back from 2050 and see what needs to be done, and to look at it all as the operators of the system, the quintessential insiders, and help people to get the best outcomes for society. Some of those things we need is to be able to place informed bets. If all of our deposits timed out like the milk in your fridge and was forfeit in time, you'd make bets. And in a way, climate change is a bit like that. This plane we have, it flies, it's beautifully reliable, and it works year in, year out, day in, day out. Problem is, it's addicted to carbon. So we need some serious bets, some well-considered investments, and some innovation in technology and process. We need to look back from 2050 and say, how are we going to get there? There are different estimates of cost abatement charges. It's widely considered that efficiency first, which is a principle adopted by governments, is the best way to abate carbon into the atmosphere. The most expensive and perhaps a signature of failure is direct air capture, which comes in around $200 a ton, estimated to become $100 a ton as the technology develops and as carbon dioxide intensity in our atmosphere increases in parts per million. So really our well-being depends upon how well we plot our escape from greenhouse gas dependency. And I think as engineers, we need to think back as to why we became engineers, and perhaps take off our corporate clothes for a moment, our corporate cultures and our vested interests, and say, what do we need to do? Now, I have a particular angle here tonight. I'm here to talk about what I believe is the best way to decarbonise, but it's true of any new technology, be it hydrogen, any new technology that can take us where we need to go needs serious consideration. And we need to ask ourselves, will the systems we have with tweaking get us there? I'm firmly convinced they won't. Second part of this is really bringing our focus into Europe, the continent we reside in, and its ambition for 2050. The Clean Planet for All, as espoused by the Commission, the 1.5 tech scenario, calls for 2,000 gigawatts of renewables, mostly wind and solar. And on your right here, you'll see a map of Europe. And in that map, Wind Europe have done an allocation of wind based on the ambition of countries, the quality of the resource, distance from market, and they've balanced it out. And for the first time, 2019, they spread 450 gigawatts, which is over twice the previous targets, in line with the Clean Planet for All. And still 750 gigawatts was onshore, and there was almost a terawatt of solar. Huge amount of renewables. An informed source, the Florence School of Regulation, opined late last year that by its very nature, renewable electricity will be cheaper than zero carbon hydrogen, which is a vector which stores it. There's an efficiency hit both ways if you're using it for electricity as an end use. And in their view, and this was no less than a former commissioner and a former head of cabinet, DG Energy, and in their view, they felt that apart from energy efficiency, which is the lowest cost abatement, the most important and immediate priority for the European Union in ensuring a cost-effective decarbonisation of its energy system must be therefore to identify and eliminate infrastructure and other bottlenecks that are likely to constrain the cost-effective production and use of renewable electricity moving forwards. So we have a big challenge on our hands. We have plenty of renewable generation. We have an abundance of resources, but they're spread around the periphery. Now, population density in Europe is very centered in the center of Europe, away from where the best renewable resources are. And here you can see a map, and it's amazing how concentrated it is from the southeast of the UK right down through the Benelux into Germany and Central Europe and down into Italy. That's where the vast majority of our people reside in Europe, hundreds of millions of people. And they don't have a great renewable resource. So they're going to struggle. They're short in renewables. So that's just a fact, a feature of our geography. And then when you look at where our best resources are, and you can see on the left is a wind map, from Wind Europe. It's actually from a European wind agency. And it has the best resources all around the northwest. Not great resources in the center and some around the coast and the Mediterranean. And on the right, you see the solar map where the solar irradiance is mapped out. And you can see that the Iberian Peninsula has a massive advantage over the rest of Europe. And into northern Scandinavia, they don't even show it because it's just not good enough. So putting solar panels there isn't a great place to put it. What I show next is what an academic in Europe did some years ago, where the seasonal share of wind and solar were mapped out. And this is normalized over a 5-year average. So each plot is done in a month. So you can see it goes from January 10 right through to January 16. So you can see the season. And you can see the solar in the summer is quite strong in Europe. And in the winter, the wind and the load increases in the winter. And this is all normalized around 1. So there's a fair amount of complementarity geographically between the wind in the north and the solar in the south around the Mediterranean basin. And what that really means is we're going to need to be able to move that power from A to B. And even with the best will in the world, with demand side management, with storage, we're still going to have to move a lot of energy around. And the most efficient way to decarbonize, remember, is to use electricity. And today, electricity only represents 25% of our energy mix. 75% can be served from electricity of our energy mix. So we see that increasing 2 to 3 times over. And in an era of free fuel, merit order CBAs are no longer meaningful. I note in the 10E, in the appendices, merit order based CBAs are still advocated to develop new infrastructure in terms of grids and projects of common interest. But we're operating on the principle that we're getting rid of carbon, and carbon is a fuel that costs. All the fuels we will rely upon in a decarbonized scenario will be free. Nuclear, hydro, wind, solar, they're free fuels. So effectively, essentially, their marginal cost is 0. So a merit order based development of infrastructure is questionable and is no longer appropriate. I think the variability of generation is a big deal. The fact that we can't dispatch all this renewable energy, that it comes with the weather. It's a regional phenomenon, so more interregional energy transmission capacity is required, more storage is required than in a carbon dispatch-based system. So today the target is 15% in Europe, and that's an increase from where it was, and some countries are getting there. I developed the East-West Interconnector and did the CBA for the Celtic Interconnector, and that's based around greater levels of connectivity between markets. But that's in a world where we all have gas turbines, where we all have oil and coal, some nuclear, and very marginal differences between one country to another. When you start getting large amounts of renewable resource in one country and a lack in another, you're going to need a lot more transmission capacity between those regions. And a regional plan to recover renewables will result in a suboptimal grid design. So for instance, if we did a North Sea only grid design, it wouldn't necessarily be the best grid to evacuate that power to the south of Europe when there was an excess of wind in the north, or to bring Europe to bring power from the south to the north when they needed it. So suboptimal will result in higher levels of curtailment, more renewables needed to do the same job, and ultimately security of supply issues, because highs can settle over regions and lows. I think it will fail to provide secure decarbonized supplies based upon renewable electricity. In terms of the challenges, I've elicited some of them there. Most of our resources are not connected to the market. Our population centres are a good proxy for demand, and they're in the centre of Europe, and our best renewable resources are around the Mediterranean and the North Seas. Some countries are long in renewable resources, while others in the centre of Europe don't have enough resources, full stop. Renewable ones. Energy is a devolved national competency, but few countries can decarbonise by themselves, and a point-to-point approach will not get us there. I think we need better than that. For 2,000 gigawatts of renewables, we're literally at 100 to 200 gigawatts today. To increase that tenfold by 2050 will require a whole different approach. I think we have issues. I think the rewards and incentives on existing utilities encourage them to be slow moving and insular. They're predominantly nationalised. Innovation is seen as more of a threat than an opportunity. So innovation gets kicked down the road. It's a tick box. It's not serious innovation to the extent that we really require. And I'll show that later, and you look at what's happening in other parts of the world where some serious innovation is ongoing. Our existing and planned grids are not fit for the purpose we need them for if you look back from 2050 to a renewables powered grid. We have transmission technology, we have R&D, we have some great programs in Europe, but they never quite make it through. They don't get trialed because there's an asymmetry of risk reward. If you keep the lights on, you get rewarded or left alone. If there's a failure, there's outcry. We saw this in the UK 2 years ago when there was a disruption on a Friday evening, and the steward's inquiry was quite remarkable. We need to work together, regulators, TSOs, DSOs, the R&D community, all the players, engineering community, gas industry, roads industry, transport, the whole lot. We need to work together to develop networks needed to power our economies cleanly, securely, and competitively. That's the task. And if we're not doing that task, if we're just tweaking the existing system and hoping it will work, we're like the committee rearranging the deck chairs on the Titanic. So what is possible? I've talked about big innovation and what's possible and things not being here and there. I think to see what's possible, we should really look to China. And in China, they've got the first ever DC network in the world. Two of them actually, and one of them is in Zhangbai, and it feeds Beijing. So you'll see at the bottom of the picture, there's a converter station. Now, this is DC technology. It's not the AC networks you'll see. So it's like our interconnectors between Ireland and Britain and the continent and Scandinavia. They're DC interconnectors. They can be overhead or underground. It's amenable to being underground. And in China, they've got a 5-terminal one, which currently feeds Beijing with 3 gigawatts, and they're going to extend that this year to be a 7-terminal with DC circuit breakers, things we've fretted about in Europe for a long time and still haven't built a DC network in Europe. In China, they're accommodating huge amounts of wind, coal as well, with lots of renewables from the northwest, and solar and wind, and they're able to bring it to their cities. They treat these like highways, and they really bring the power a long distance. So I think in China, it's a bigger country. It's almost a continent itself. So they're able to trial all this. Their circuits are like autobahns, and their scale enables interregional transmission at a scale never seen before. So renewables can be brought thousands of miles from where the renewables are strong to where the demand is near the sea, near Beijing. So this line is a 3,324 kilometer line. It carries 12 gigawatts. Now 12 gigawatts is over twice the national demand in Ireland. So that's 40,000 gigawatt kilometers. It takes us a long time to build that kind of scale in Europe. This is it. It's going from Shanghai converter station down to Guquan near Shanghai. And this is what the infrastructure looks like. So it's actually a massive pylon over 300 meters tall. And there's thousands of these crisscrossing right across the landscape. And on your left, you'll see one of the teams working, repairing a pole, doing some maintenance. And you can see the size of the insulator strings. So this is a massive piece of infrastructure, not one that I think we could build or deliver with public acceptability in Europe. But we have the same challenge in Europe. We want to move to more renewable resources, and they're going to be a long way from our demand centres. So we're going to have to take inspiration. We can't adopt the same approach. In Europe, I believe we need underground transmission technology that's publicly acceptable and deployable in a marine setting also because of our geography. We need DC grids meshed so that we don't have to limit the size of each link to be 1 or 2 or 3 gigawatts, whatever the maximum single in-feed is. With meshed DC grids, we can carry more power reliably, just like we do on the AC network. And I think that's the future if we're to achieve a renewable powered electrification of our energy system. So that means transport and heat being electrified. This requires a plan, and that's where the engineers come in. I think international cooperation for a pan-European grid is an essential to achieve this. I don't think we can do it properly at all in many countries, and few countries can do it at minimum cost. Cooperation is the key here. These are the bold steps that we need to take. And as engineers, we need to take the boldness out of these steps because people will be fearful and we have a role to play. This is a study carried out by E3G consultants to the European Commission, amongst others, in Europe earlier this year. And they did a comparison. Now, this is a North Sea only grid, and I'm not an advocate for regional optimization. I believe in a pan-European optimization, but the lessons here are equally appropriate. And they see that for a network in the North Sea, which would be one of the first places to be fully exploited for its offshore resources, the cost of having an integrated meshed grid is approximately half that. Now the scenarios change. They're using Wind Europe projections for the North Sea for generation, and they're using ENSWE projections for onshore demand. Some are lower and higher, but the key point here is if we do this on an integrated basis, we're going to save ourselves a lot on transmission. And we're going to get a lot more renewable resources to market. Which brings me to my own interest. In Supernode, we're developing technology to improve the competitiveness of superconductors. So I'll just talk a little bit about superconductors. A superconductor is a material that can conduct electricity with zero resistance, so there are no losses. In order for the material to be superconductive, it must be kept below its critical temperature. In recent years, critical temperatures have gotten up to 77 degrees Kelvin, and that means new cryogens like liquid nitrogen can be used, and for lower temperatures, there's helium and hydrogen, and other alternatives are available too. The European Commission had a Horizons Best Paths project in 2018, a great piece of work, and they did a prototype, gigawatt scale, 320 kV superconductor, and the outcome was they said that they could put 7 or 8 gigawatts on a single line. That's not something we can do with copper. And on the bottom left-hand corner, you can see a 10 kiloamp superconductor beside a euro coin, and also in comparison with a 2 kiloamp copper cable. Now the copper cable has an insulator around it, so it heats up. So the big limitation with copper cables is the current carrying capability is lower. So with a superconductor, you have no resistance, so you have no losses. So you can carry much more current in a smaller wave, reliably, safely, securely, and economically, we believe. Bulk power transfer. Superconducting technology, it's deployed in urban settings right around the world, in Asia, in America, and here in Europe. Typically to replace copper and aluminium where the power density is not enough in an urban setting where there isn't space, or the space is very expensive. The cost is largely fixed, so the cost of a superconductor as you increase the scale does not increase like with a copper, because you just put more current through the same superconducting tape and add more tapes, and the cost of cooling it is fixed. So for 6 to 12 gigawatt links like you see in China, there's no realistic alternative to superconductors, and even with today's technology, they're more economic. What we're trying to do in Supernode is to bring down the crossing point of those two. So the brown line, the orange line here is copper, and the green line is the superconductor. And what we're doing is reducing the cost of managing the thermal load by reducing the heat ingress and improving the efficiency of the cryogenic process. Last year, we did a world first in that we got a statement of feasibility for a subsea superconducting cable system. This was done in France with a partner of ours. And what you see here is the external cryogen, and inside that there's a vacuum, there's insulation, and that's all designed to keep the superconductor cool. And inside that there's a very special particular steel called Invar, which has a very low coefficient of thermal expansion. So when this heats up and cools down, the integrity of the system is maintained, and the vacuum in particular. This was something we did to baseline our own technology, and it's very useful. And we also got our statement of feasibility, which we were delighted to get from DNVGL. Superconducting cables, among other innovative technologies. So I should highlight that the problem space is so vast that other technologies, storage, demand side management, hydrogen, they will all play a role. Molecules will also play a role in getting us to decarbonisation. I've no doubt about that. Superconductors and electricity, I do think, can be the main vector. So coming on to the last part now, and suggestions to realise our potential. And I can see that we should work back from 2050. I'm working back from 2050 and a renewables powered grid where the interregional transfer and flexibility and a much greater level of connectivity between markets so that everybody can share, and we can reduce the amount of investment and reduce the level of curtailment and ultimately the cost of grid if we do it on a national basis. And that will require an architect, an entity empowered by policymakers. And that's not a treaty change. That's something that could be done with a multilateral agreement between the European Commission, the UK, and Norway and other like-minded neighbours, to empower an architect, an independent system operator, pretty much like the independent system operators you see in the US, where they manage assets. They don't own them, but they manage them and operate them for the benefit of all the members. Something like that in Europe, rather than a collection of entities with nationalistic priorities, a regional approach to optimization is the best way to get the best outcome. It would reverse the trend of member states trying to go it alone. We also need to facilitate innovation, not just innovation for the sake of it, but market shaping grid innovation, the type of innovation that will change the game, that will enable us to break out of the system of dependency we have on carbon and avoid closed shop innovation and transmission. In generation, this gave us offshore wind at prices below coal. It gave us solar at a cent a kilowatt hour. It gave us floating offshore. It's given us a huge array of tools to combat climate change. We need it in transmission now. We need to get rid of the bottlenecks, like the Florence School of Regulation said. We need to start funding. So we need to encourage the regulators and the policymakers to allow the transmission system operators and the utilities to do the innovation with partners and to bring it on. This will be a springboard And we should see our systems as not an immovable feast that we operate without change, with minor tweaks. We should see them as a springboard to future success, as they do in China. In conclusion, as an industry, I believe the electricity sector needs to be more ambitious in terms of what electricity can do in terms of decarbonisation. If you do the maths, and as engineers, you'll be able to do the maths, the efficiency, the lower losses, the technology advantages of using electricity are far superior to any other way. So if we end up using suboptimal ways to decarbonise, we'll pay the cost in terms of jobs and competitiveness. Renewable generation technology is available in abundance. It can competitively power our economies, and electrification is the most efficient and economic way to decarbonise. Our networks are a constraint. They're not fit for purpose at the moment. I don't believe anyone is claiming they're fit for purpose for 2050, perhaps for 2030, but certainly not for 2050. We need an engineer's mindset to lead the way. We owe it to people to lead the way. We're the only vocation who are all over this, where we operate these systems, we design them. We need international cooperation in a single energy market. And I believe if we paint a plan and a picture, it can be adopted, and it will be adopted by policymakers. I also think that superconducting technology can be a building block for such a grid. Thank you.
On behalf of all the attendees, I would like to thank you for your time and for, I guess, your very specific, I guess, subject and pointing at it from an engineer's perspective, which is, is really good, and trying to bring in our skill set as problem solvers. We all love to do that, and there's not many bigger problems out there to be solved. So I think it's great to have someone from engineers, an engineer from Ireland, who is thinking very big and thinking long term for solutions on this, and it's been really.
So I should actually mention a book I'm reading at the moment, which actually rhymes with what I've said, which is why I'm enjoying it so much. I guess we're all a bit like that. Bill Gates has a book called How to Avoid a Climate Disaster. Mm-hmm. So I'd recommend it, and he has a section on electricity, and he talks about how we're going to have to make some informed choices and some bets. So I think there's a big role for Engineers Ireland to help society arrive at the best solutions and make the best choices and bets, and to make the bets, because the alternative to not making a bet is probably failure. Mm-hmm. And we're not big gamblers in this industry.
Yeah,
so we got to do a bit of innovation.
We have some great minds, and we have done great things, in fairness, I think, up to 2020. So I think we have the ability to do it, like you said. And
good.
show leadership.
It's definitely needed. Yeah.
Okay. Okay. Listen, we will close there, but I do.